Hello friends, welcome to the tutorial series on network analysis made simple. In this tutorial, we shall solve the questions on network solutions from IES examination. Friends, it is given that the circuit shown in figure is linear, time invariant, and the sources are ideal. We are required to find the voltage across and the current through 1 ohm resistance. Friends, in simple terms, linear circuit is one in which if linear input x of t is applied to the circuit containing linear elements, the output y of t also will be linear. Time invariance also is another property of the circuit. When the input is x of t and the output is y of t, the output y of t, if is not dependent on the time when the input x of t is applied, such system is called as the time invariant system. Further, it is given that the sources are ideal. You find that 5-volt source is directly connected across 1 ohm resistance, and the most important point is the current source of 1 ampere does not drive any current to the branch containing 1 ohm resistance. This you have to understand. So, voltage across 1 ohm is 5 volts and current through it is 5 amperes. Hence, option C is the correct answer. Friends, in this question, the capacitor of 2 microfarad and 400 volts is given. We are required to obtain the number of capacitances required to get a capacitance of rating 1.5 microfarads and 1600 volts. To get 1600 volts, we need to use 4 capacitors in series as shown in figure. By doing so, we get an equivalent capacitance of 2 microfarad divided by 4 equal to 0.5 microfarads. But we need 1.5 microfarad capacitance. So, if we connect such 3 rows in parallel as seen in figure, we get the required capacitance of 0.5 microfarad into 3 equal to 1.5 microfarads of 1600 volts rating as shown. So, totally we need 4 into 3 rows of 4 capacitors each equal to 12 capacitances. Hence, option A is the correct answer. Friends, in this question, two inductance coils, one of 10 millihenries and the other of 15 millihenries are given. If they are connected in series aiding mode, it is given that the effective inductance is 40 millihenries. We are required to find the effective inductance if these coils are connected in series opposing mode. We know when they are connected in series aiding mode, L equivalent is equal to L1 plus L2 plus 2M. We know L1 and L2 and effective inductance. Hence, we can find M. By substituting the values and solving, we get M is equal to 7.5 millihenries. But we know When they are connected in series opposing mode, L equivalent is equal to L1 plus L2 minus 2M. By substituting the values and solving, we get L equivalent is equal to 10 millihenries. Hence, option B is the correct answer. Friends, in this question, two circuits, circuit A and circuit B, are given. For the two circuits are to be dual to each other, we need to identify the correct combination of the dual elements in circuit B. The list of duals for your reference is given in the table. We know that the dual of resistance R is the conductance or the reciprocal of the resistance, that is 1 over R. Similarly, the dual of inductance L is the capacitance C and the dual of capacitance C is L. So, R dash is equal to 1 over R, L dash is equal to C and C dash is equal to L. Hence, option A is the correct answer. Friends, in this problem, the sinusoidal function f of t is equal to sine 1.1t plus sine 3.3t is given. We are required to find the period of the function. Note, the given function contains fundamental and third harmonics. In such a situation, usually the period of the fundamental component is specified. We know that T is equal to 1 divided by F, but omega is equal to 2 pi F. So, if we know omega, we can find T. From the given function, we find that omega 1 is equal to 1.1 radians per second. So, 1.1 is equal to 2 pi of 1, from which we get T is equal to 2 pi divided by 1.1. It is the period of the fundamental component. But what about the harmonic component sine 3.3t? We see that this frequency is 3 times the fundamental. So, it is the third harmonic component. Let its frequency be omega 3 and omega 3 is equal to 3.3 radians per second, from which we get omega 3 is equal to 3 times omega 1. Hence, option B is the correct answer. Friends, in this problem, we are required to find the node voltage VB in the circuit shown in figure. The problem is simple and straightforward. To make the solution simple, we shall convert the current source of 1 angle 0 amperes. By converting it, we get J2 volts in series with J2 ohm as shown in figure. Let VB be the unknown node voltage of node B. By writing the nodal equation for node B, we get VB minus J2 divided by J5 plus VB divided by J4 minus 2 angle 0 is equal to 0. By solving this simple equation, we get VB is equal to J 5.33 volts. Hence, option A is the correct answer. Friends, next we shall solve question 7. In this question, it is given that we are required to find current through L and the voltage across C2 in the given circuit shown in figure. Observe the given circuit. Note that current source of I amperes is connected and it is a DC current source. This is the important observation that you have to make. We know that when DC source is applied for a long time or for infinite time, the circuit will attain steady state. So, under steady state, L is short and C is open. Incorporating these aspects, the circuit drawn is shown in figure. From the figure, we find that current of I amperes will flow through L and R, and the voltage across C2 is I into R volts. Hence, option D is the correct answer. Friends, this problem is very easy but tricky. We are required to find the resistance seen from the terminals A and B of the device whose VI characteristics is shown in figure. The problem can be solved in different ways. From the characteristics, we find that when I is equal to 0, V is equal to 20 volts, this is the open circuit voltage. When V is equal to 0, I is equal to minus 4 amperes, and this is the short circuit current. So, VOC upon ISC is equal to 5 ohms. Also, we know that according to Kirchhoff's voltage law, algebraic sum of the potential differences in a closed circuit is 0. So, V plus IR is equal to 0. By substituting the values and solving, we get R is equal to 5 ohm. Another way of looking at the problem is consider the circuit inside the black box as shown in figure. We know that the current in a passive element flows from positive to negative where the polarity is of the voltage across the resistance R. The current shown in red is the true direction of current I, whereas shown in black is flowing in the opposite direction of true current. By tracing the circuit in anti-clockwise direction, we get V plus IR is equal to 0. By substituting the values and solving, we get R is equal to 5 ohm. Hence, option D is the correct answer. Friends, we have solved few interesting questions in this tutorial. During the next tutorial, we shall meet to solve some more problems. Hope this presentation has kindled some of your thoughts. Thank you for watching.